I'd like to take a look at just graphing exponential equations, just in case you are struggling with that or answering some of the questions. So we'll just go through it again. Similar to graphing everything else, you're probably going to want to use table to figure it out. So again, when you're doing graphs, you probably want to make use of table. So here I've been given some information, exponential. I can see it's exponential because the x is in the power, so that reminds me that it's an exponential. The following equation can be used to model the amount of money in a savings account over time in years. So here I'm going to assume that this means the amount of money. That's the money, and x we're going to say is the time. So here this is going to be time, and this is going to be money. So first thing we're being asked to do is make a graph for this. Now, as a hint that you should use for pretty much any graph that you make, keep aware of setting your scales in both table and on a graph to match what's actually been given to you here. So let's go into table, and I do see there's a function there, but I need to delete it. I don't want it. And we'll enter in what we've got here. Again, I only enter in what's after the equal sign. So 200 times 1.02 to the power of x. So again, we use that hat button, the little arrow pointing up. So when you're using an exponential in table, 200 times 1.02, it's the times button, hat button, and then you use the variable x. And press execute. Here we've got that table. If I press table again, I'll probably just get random numbers that are not very helpful. So when you do that, go back and let's look at setting so we can get values that are actually helpful for us. And because they've given you a graph to fill in, like they've given you the grid, let's use that as our hint. I can see always that I want to use my set ability with the calculator to match with the x-axis. So here I go from 0 to 50 and a little bit further. So maybe I should go from 0 and we'll try 60 just to go that little bit further. The next thing I want to do is my step. I'm noticing that that just goes up in 2s, and I probably don't need every single point. So let's try 5s and just see how that looks, because that would give me heaps of points to get my line on there quite nice. So here we go, back in the table, put it out, and now I've got some numbers that might help me figure out how to plot this thing. So 0 to 200, get that one easy. Let's just try the 10s and see if we need to put any more. So at 10, it's going to be at 243.79. So at 10, let's see how these are going up. Looks like that would be 225, 250, 275, 300. These are going up in 25s. So at 10, that's 225. That would be 250. 243 would be slightly below that. Again, sometimes you're approximating because you can't read the scales that precisely. Keep going to 20, and you'll notice that's very close to 300, but just ever so slightly below it. And another point. Looking at 30, I see 362. So again, that's 325, 350, 362 would be somewhere in there. 40, I see 441. So 25, 50 before the 50. Sorry. And up to the year 50. So 538. 5, looks like we've almost got it on there. That would be 525. Above it would be 550, so we'll just put it right at the top there because that might be about 538. So that's pretty good. I could go in and put in a few more points if I wanted to, and I might just do that right at the start, just that first one at 5 to help me start it out a bit smoother. So that would be 25, 222, or 220 would be somewhere just below that line. So now I've got some points, and I can draw my line on. Now, it's always a bit tricky, but you just do your best to try to connect it. And remember, an exponential is kind of curving upwards, it's something that's going up, so I wouldn't connect those lines in a straight way, but I'd try to get some sort of curve going on in there. So there's my graph. Again, make sure you use your set button to get your scales correct to help give you numbers that are helpful. Next thing that we're looking at here is just a few questions about that equation. Now you might be aware of some of the information in the equation if you've watched some of the other videos, but the initial amount deposited, what is that? Like on the graph, where do I look for the initial amount? That's not at t50, that would be at the end, but the initial would be at t equals 0. That's the initial amount, and I can see here that it's 200. So $200, sorry, $200, and that is also my y-intercept, and it's also equal to a in the general transform format of the equation. So I can see it right here as well. 200, that is the initial amount. Now the next question here is, what is the interest rate of the savings account? Well, the interest rate, that comes out of this part of the equation, and I can see that it's 1.02. So we do go into detail in some of the other videos about how to work from a rate to the actual formula, but just so that you get a chance to see this, that 1.02, what happens if you convert 1.02 into a percentage? We times by 100 and we get 100 into percent. So looking at what's happening here, it is getting bigger, and what's happening is that it's getting bigger by 2% each time. So that 100 would be that you'd have the same thing every year. It would stay at 200. Every year it would be 200. It would never change. The 2% means that each year it gets 2% bigger than it was the year before. So the interest rate here is 2% per year, because we're dealing with years here. So again, another video will go into detail about getting those rates out of there, but just so that you're aware of it. So here our initial amount is also our y-intercept, where it crosses the y-axis. You can see that as 2, and the rate there is 2% per year. Don't forget, when you're putting it into table or into the calculator for your exponential, you use the little hat button there.